Today we're looking at the notes page for our special right triangles. So as we're taking a look at our filling in the blanks for our angle measures of 45, 45, and 90, and our lengths of x, x, and x square root 2, we know that we have a 90-degree angle here where we've got the right angle symbol, and each of the other two angles are 45 degrees. The sides across from those angles are the ones that are indicated. So for each of the lengths of the legs across from the 45-degree angle is a length of x, across from the other 45-degree angle a length of x, and across from the 90-degree angle a length of x times the square root of 2. That's our shortcut for our 45, 45, 90 triangles. If I'm looking at an actual example question, if I have a leg of length 2 feet, I know that the other leg will be the same 2 feet, and the hypotenuse will be 2 times the square root of 2. And since I'm actually trying to measure things in feet, I'd probably want to go ahead and find out what that value is. So in my calculator, I would type in 2 times the square root of 2, and that gives me a value of about 2.83 feet. So as I'm filling in my chart, my angle measure 45 degrees, the side opposite is x. On this actual diagram, that is 2 feet. The other x, again 2 feet. And my x square root 2 would be 2 square root 2, or 2.83 feet. If I'm looking at the last example problem, I've got the hypotenuse of 1.3 miles. I'm looking to see what each length of the leg is. I can fill in the table that my actual value, 1.3 miles. But in order to find that missing length, I know that 1.3 is equal to some number x times the square root of 2. In order to find that missing value, I'm going to divide each side of the equation by the square root of 2. And since I'm looking for a decimal approximation, I'm going to go ahead and put this value in my calculator. .3 divided by the square root of 2, and that gives me 0.919, or close to 0.92. So each of the lengths of those legs is 0.92 miles. Whereas the hypotenuse is 1.3 miles. So I've determined the actual value. I can double check to see, did I get close to that 1.3 miles? By multiplying 0.92 times the square root of 2, and that's pretty close to the 1.3 miles that they were giving me. On the back side of the page, we're looking at our 30, 60, 90 degree special right triangles. So the relationship that we have with those problems. Again, I have the 90-degree angle marked. The smallest angle is my 30-degree angle. The other angle, my 60-degree angle. And the sides across from those angles are what are given to me in my table. Across from the 30-degree angle is my length of x. Across from my 60-degree angle is my length of x times the square root of 3. And across from my 90-degree angle is my length of 2 times x. When I'm looking at an actual triangle, if they're giving me the length of the